Welcome back. Today is day 21 of this 30 days Leetcode challenge, and today's question is leftmost column with at least a 1. So let's get started. A binary matrix means that all elements are 0 or 1. So we are given a binary matrix and it contains only elements 0 and 1. For each individual row of the matrix, this row is sorted in non-decreasing order. So the row has already been sorted. So initially we'll have zeros and then we'll have ones if there are ones in that particular row. So the array or the matrix, the 2D matrix is sorted row wise, and we are given a row sorted binary matrix, and we have to return the leftmost column 0 index with at least a 1 in it. So we have to return the first column which has at least one in it. And if there is no such column, meaning all the elements in the matrix are 0, then we have to return -1. Now, ideally, what in normal scenarios we would do is we'll just iterate column wise and figure out which column has the first one, and as soon as we find a one, we can return the index of that particular column. But there are some additional restrictions imposed here. So you can't access the binary matrix directly. So we cannot access the matrix directly, but we have to use this two functions. The get function for a particular row and a column will return the element of that matrix. So for x row and y column, whatever element is present can be obtained using this get method, and the number of rows and columns can be obtained using this dimensions method, which even though it says here it returns an array, but it's actually array list of Java. So n is the number of rows and m is the number of columns that get returned from this matrix. Now the reason we cannot just directly iterate through the columns and return the first index is because we can at max we can make 1,000 calls to this get method, and if we make more than 1,000 calls, then our answer will be getting a wrong answer in that case. So let's say if a matrix contains 1,000 columns, then 1,000 rows, and let's say there are only two columns and the second column has one, then while you iterate through each of the row, you'll end up getting a wrong answer because you'll be iterating through the 1,000 columns in that case. So what you really want to do is find the optimal way to iterate through the matrix. So that is what we are going to do. So if you look at this example, in this example, the first column itself has 1, so we'll return index 0 of that particular column. In the second one, the one is present. The first one is present at index 1, column 1. And in this case there is no one present, so we'll return the output as -1. In this case the second column, so index 1 has the first one, so the output is 1 in this case. So what our algorithm will be that we'll start off from the top right element of this 2D matrix, and let me explain using this. So we'll start off from the top right element, and we'll continue iterating through the row as long as we keep finding ones. So as long as we keep finding ones, that simply means that there is a column with a lesser index that contains a 1. Now when we reach a column that contains 0, that simply means that all the elements after that particular column in that row will be 0. So we'll just switch the rows in that case, and as long as we keep getting zeros, we'll keep traversing each row. And when we start finding 1, that means that we'll find a column with index that is less than what we had already found. So if you look at this matrix, after this one, we can be guaranteed that all the elements after this 1 will be 1. But and all the elements to the left of the zeros will be zeros. So that is what we are going to do in our code as well. So we'll keep 2 pointers. So let me just reset the solution. So I'll write the code. So what we want is first to find the dimension of the matrix. So let's call this dimens, and we'll get this using the binary matrix method dimensions. And the max row in this case will be dimens dot get 0, the element that is present at index 0, and the number of max columns can be obtained using get 1. So this will be the maximum rows and maximum columns, and our first uh, row will start off from 0th index. So we'll start off from the first row itself, and our column will start from the last element. So the column in this case will be whatever is max column minus 1. That will be the index. Now what we'll do is in this case, so if you look at this, what is going to happen is our column will be decreasing as we move left. So as long as we keep getting ones, we'll be moving left, and our columns will be decreasing. So the maximum value, the last value when the iteration should stop is when the column becomes, as long as the column is greater than or equal to 0. And as far as rows are concerned, rows will be increasing whenever we find a 0. So the maximum value the row can obtain will be the maximum rows that are available. So our I, or the maximum rows will always have to be less than or equal to the max row, and the column, since this will be a decreasing value, so it will always have to be greater than or equal to 0. So these are the valid boundary conditions, and what we'll do is if we find that binary matrix for a particular row, for this row and column, if we find that that is equal to 1, then we'll have to keep track of our result. So we'll initialize the result value with -1, and that is what will end up returning the result. So whenever we find a 1, we'll update the result with whatever value is present in the column, and just decrease our column. Else, whenever we find a 0, so in that case we'll just increase the rows. So let's submit this. This should work out fine. So for this matrix, yeah, it is working out. So let's submit our solution and check if it passes all the test cases. There is an assertion error. Okay, so this will be max row -1. That will be the largest value. So let's run this and check. Let's submit. Yeah, so our solution has been accepted, and yeah, uh, it works. So thank you guys. Thank you for your time, and if you want to be notified about our day 22 problem, then do subscribe to my channel and click on that bell icon. So thank you.